All right, here we go. 5-6 Law of Cosines today. Now we've talked a little bit in the past about how or why there are some triangles that you can't solve using Law of Sines. And you'll have two variables in the proportion for the Law of Sines that can't be solved. So in comes Law of Cosines. Law of cosines is used when you have, first of all, three sides. Side, side, side is a postulate. Now you can't solve that with the law of sines. You need law of cosines. You'd have both angles would be variables. And the second one, two sides and the included angle. Angle in between the two sides. That's what included angle means. So if you have 10, 15, and 30 degrees, if you try to use law of sines for that, you're again going to have two variables in the proportion. So we need what's called the law of cosines to finish this one. Now here is one example. Well, let me say this. Given triangle ABC with sides ABC, in other words, angle A is opposite side A, angle B is opposite side B, and so on. Here is the law of cosines. Now it looks a lot like the Pythagorean theorem, and I'm sure if you look at the proof in the book, they probably use Pythagorean theorem somehow. The one thing you need to notice for the law of cosines is if you start the equation with side A, it ends with cosine of angle A. Well, if you had angle A, let's say 20 degrees, 20, there you go, 20, and you wanted to know side A, but you had the included sides, that you'd be solving for side A. And cosine A would have a value. Now, if you're looking for side A or angle B, that's what it's going to look like. It's really the exact same formula, except you're trying to find something other than side A. Let's say side B. Or you could be looking for angle B on this one. And likewise, this is not a completely different formula, of course. That's just with different variables thrown in depending on what you want to find. So as you might suspect up there, there's really only one equation. Just change variables depending on what you want. Right. So that, as far as notes are concerned, that's the only thing we really need to know. Law of cosines, now we just need to be able to use it. So for the three angle, let's see, find the three angles of the triangle whose sides have the lengths 8, 19, and 14. All right, so let's make this side the 8. That's the shorter side. That's the shortest side. I need the long side and a slightly shorter than that side. So if this was 8, this is maybe 19, and that could be 14. I should probably made it a little shallower of an angle. And now this must be A up here. This would have to be B, and this has to be C. So we're trying to find angle A, B, and C. Well, we have to start somewhere. How about angle A? So we have side A, so it starts out with 8 squared equals 19 squared plus 14 squared minus 2 times 19 times 14 times the cosine of, I used 8, so I must be doing angle A. Now you have to be careful with this. Grab your calculators. I know what 8 squared is, it's 64. Let's find out what 19 squared plus 14 squared is. I get 557, and then minus 2 times 19 times 14. 532 cosine of A. And if you're really careless with this, you will take 557 minus 532. You can't subtract these two numbers. You can't do that because 532 is still with multiplication. You'd be doing this out of order, way out of order. The next step to solve for A, angle A, is minus 557 from both sides. 64 minus 557. Negative 493 equals negative 532 cosine of A. So we needed to divide by negative 532. And I get cosine of A equals 0.9266. Keep on going. But we're going to take the inverse cosine of that value, inverse cosine of answer, and I finally get 22.075 degrees. We could, now that we have this as 22.075, we could do sine of 8, or 8 over sine of 22.075 equals 19 over sine of B, and we could use law of sines. But here's why I'm going to explain why I really don't want you to do that. I want you to use the law of cosines to get the next angle. Grab your calculators. Type in inverse sine. This isn't really part of the problem. Type in inverse sine of, I don't know, how about 0.5? That should give you 30 degrees, right? Because sine of 30 is 0.5. It's a half. Now do inverse sine of negative 0.5. What does it give you? Negative 30, right? Why could that be a problem? No, not more than 180, but more than 90, right? Obtuse. What about obtuse angles? What if you have an obtuse angle in your triangle? How are you going to use law of sines to get that obtuse answer? You'll just have to know it's obtuse. And if you get that acute angle, like if this is the angle you got, but the answer was really 160, you'd have to know to subtract, or 150. You'd have to know to subtract that from 180. Now we could come up with a bunch of rules when the triangle looks like this and use law of sines. Make sure you do this. Maybe come up with 2 or 3 of those that would cover all possibilities. But why don't we just use law of cosines instead of making up a bunch of rules? Law of cosines, well, here's the reason why you're not getting any obtuse angles. Because when we do inverse sine, don't they have to come from 1 and 4? So they're coming from negative 90 to 90. Where does cosine come from? You remember? When you do inverse cosine, where are the principal values? What quadrants? 1 and 2. 1 and 2. That's from 0 to 180. So that's why you can get some obtuse angles with cosine. So here's what I'm trying to tell you. If you have to use law of cosines to solve a triangle and you need all 3 angles, just use law of cosines twice and you'll never have to guess whether it's obtuse or not. The answer will literally tell you. All right, so that's my message. Well, let's solve for B and then we can just subtract from 180 to get C. So 19 squared equals, what do I need? I need 8 and 14. 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of B. $19 squared, 361. 8 squared plus 14 squared. That is 260. 2 times 8 times 14. 224 cosine of B. Now you cannot take 260 minus 224. Do not do that. You have to minus the 260 over. So 361 minus 260. 101 equals negative 224 cosine of B. Divide by negative 224. So cosine of B equals negative 0.451. Inverse cosine of answer, and it's 116 degrees, 0.801 degrees. So my drawing is not very good. Not very good at all. 116.801 degrees. So now I don't have to depend on an accurate drawing because it actually is an obtuse angle, not an acute. Now, if we would have used the law of sines to keep going with this, it would have told us an acute angle, and that would have been wrong. All right, so now I can just add 22.075 minus it from 180, and we got the remaining one, 41.124 degrees. There's the three angles. We already had the three sides. My favorite two sides are coleslaw and barbecued beans. That's usually what I get for my sides. Or French fries sometimes. That'd be my three sides. All right, example 2. Hard to focus on this now, isn't it? Solve triangle ABC given A is 11, B is 5, C is 20 degrees. All right, let's see if I can do a better job of drawing this one. I missed the last one. 20 degrees, and well, this side needs to be 5. I better shorten this one up a little bit so I can make the other one 11. 20 degrees with 11, like that, maybe like this. That's C. This, if I make this 5, that puts B up there. If I make this one 11, that puts A down there. And this is 20. A, B, C. A, B, C. I already know C is 20. I know B is 5, and I know A is 11. We have, I need this right here, C. Yeah, side C first. C squared equals B squared plus A squared minus 2 times B times A times the cosine of 20. Now this one is a little different from the first one because the right side is all values now. So we can just type in the right side just like we see it. 5 squared plus 11 squared minus 2 times 5 times 11 times the cosine of 20. C squared equals 42.634. Take the square root of that, and C is 6.529. Now hopefully, if you look at that answer of 42.634, you know you're not done, because look, it's 11 and 5, and I don't think 42 is really going to fit into that triangle. So hopefully that'll tell you that, whoa, you haven't taken the square root of that yet. All right, so now we have to find an angle, and I know this is 6.529. Now we try not to use rounded answers in here, so let's store this. Let's store this value that's sitting in our calculator into, and let's store it into C because it's side C. Anyone not know how to store it? Store alpha C. Oh, how about we get angle B, I guess. That means we have 5 squared equals, that's 6.529 squared plus 11 squared minus 2 times 11 times 6.529 times the cosine of, and I'm trying to find angle B. Now you can do all this in one shot, not one shot, but you can do 5 squared minus this as long as you put this in parentheses in your calculator. So you can do 25 minus parentheses C squared plus 11 squared. I get negative 138.633 equals negative 2 times 11 times C, which is 143.648 cosine of B. So the next step is to divide. Oh, I guess that's going to be rounded. I mean, if we use a couple rounded values, that's not going to be horrible. Negative 138.633 divided by negative 143.648. I get 0.964 approximately, inverse cosine of the answer. B equals 15.228. That tells me that my drawing was a little bit more accurate than the first one. Add that to 20, minus that from 180, and you get 144.772 degrees. And there it all is right there. Any questions on this one? Law of cosines. Use law of cosines a couple times and you don't have to guess if you've found the right one or not. If you found the acute and it needs to be obtuse, you don't have to guess or come up with any kind of rules. Here's the last one. Make sure you jot this down right here. And that it's going 80 miles in that direction and 60 miles east. That's the important information. A ship travels 60 miles due east, then adjusts its course to north 15 degrees east. After traveling 80 miles in that direction, how far is the ship from its point of departure? We have to start somewhere. The ship travels east for 60 miles. Let's call that 60. And then changes course, not straight north, but 15 degrees east of north. So we have to go on the right side, which would be east of north, and now it's traveling 15 degrees off of north, but to the east side, to the right side. The value they want is this distance right here. If this is 80. They want to know that distance right there. Now if I call this angle something, theta, then we have d squared equals 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of, and I can find out what theta is. If this is 90 and then another 15 degrees, we're looking at 105 degrees. So now you just have to find the value on the right-hand side, square root it, and we got it. 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of 105. So D equals, I have this 12,484. That's certainly not the answer. Square root of that is 111.735 miles.